Okay, here we go. Yesterday we talked about length of a line. That's where we're going to do the same thing now, but we're going to put it on a graph. And we'll talk, oh, that's easy to find the length of the line versus that might be a little difficult. So what I need you to do in this first case, we're going to draw line segment AB on the graph, but now we're going to have coordinates. All right, so point A is going to be at 2, 3. Point B is going to be at 7, 3. Okay, and then if you want as well, since we're already on the same, we're going to use the same graph, you can also draw me segment CD with C and D having those coordinates. Okay, so go ahead, draw segment AB and segment CD right now. I'll do the same on mine. Yes. Okay, how are we doing? All right. Okay, now take a look at part B. Find AB. Let's go back to yesterday. I got rid of the segment symbol on top. What's that asking me now? Find the length. Okay, I'm going to start using the word distance as well today. Find the length. Find the distance of AB. Pretty easy for us to find the length. How are you going to do it? Begins with the C, ends in out. Count. Good. You guys are picking that up pretty quickly. Yep, go ahead. Count, and you find the distance of AB is what? 5. All right. And then same thing here. You take a look at part D. I dropped the line segment symbol. So now we're looking for the distance of CD. Can I count that now? And how long CD? 3 units. No issues, right? No big deal. All right. What's so tough about today? Well, let's go down to number 2, and we'll find out what's so tough. Go ahead, draw EF in for me now. Segment EF with those coordinates. We got a problem we're going to run into. All right, we run into a little issue. Can't count. Some of you may think you count, and you're going to go, don't pull this on me. Oh, 1, 2, 3, 4, maybe 4.5. We'll go with 4.5. That's not how we do that. All right, we don't count. All right, the only thing we can count is that vertical and horizontal line we had above. So we need a new method right now to find how long that line is. All right, a new method. I'm going to show you 2 methods. You pick whichever one you prefer. Last year, did you have any experience with the Pythagorean theorem? Oh, you did. Okay. To use Pythagorean theorem, you had to have what type of triangle? A right triangle. That's what I can do here. I can make a right triangle out of this line segment. Take a look. I can go up and over, or I can go down and over. All right, you decide. And notice, everyone see your right triangle. Can you find out how long one leg is and how long the other leg is for me? We can count just like we did above. So no matter how you did it, how long is the vertical leg you drew in? 4. And how long is the horizontal leg you drew in? 2. And what is your segment that we're trying to find the length of acting as? What's that called in the right triangle? Evan? The hypotenuse. Everyone see that? So I can go one way. All right, so I'm just going to put a number 1 here because there's a second way I'm going to show you. And that is the following. Pythagorean theorem. So I could say 4 squared plus 2 squared equals c squared. 16 plus 4 equals c squared. 20. What do you do at this point right here? 20 equals c squared. Take the square root both sides. And notice my directions, and I'm giving you these directions because you're in honors geometry. Simplest radical form, which means don't go to your calculator and tell me that it's 4 point da 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 da. All right, break this down. And they told me in my 8th period class yesterday that you guys had practice with this last year. Breaking down a radical. Yes, no? Okay, so I may do it differently than you were taught last year. I break it up into 2 radicals. In one radical goes the biggest perfect square, 4, 9, 16, 25, 36. Those are all perfect squares. The biggest one of those that goes into 20 evenly. Perfect square that goes into there evenly. 4. And what do you multiply 4 by to get 20? 5. One more step. Square root of 4. 2. And the square root of 5 comes along for the ride. So there's the length of EF. Again, if you are having issues with simplest radical form, come on, stop in and see me. We can brush up on it real quick because that's what I'm going to ask a lot of. It is very rare that I'm going to ask you for nearest 10th. All right, not at the honors level anyway. Everyone good on that method? Okay, that's not a bad method, right? But what if we run into the problem where these are really big numbers that you can't graph, or they're decimals? Like what if this was 2.75, 1.38, and I still ask for the distance? Is this really going to help us too much? Graphing it and doing Pythagorean theorem? No, it's not. You're right. Absolutely not. So what I have instead is an alternative method called the distance formula. All right, the distance formula. And it is the following. D equals D for distance. And this can be used anytime you find the length of a line segment. Big square root. And underneath the square root, x2 minus x1. And I'll talk about what all this means in a second. Squared plus y2 minus y1 squared. These are not exponents. These are what's called subscripts. Okay. So real quickly, let me show you what everything means, and then we'll use it up here again. x2 and x1, those are the x coordinates. Okay. Those are the x coordinates. Those are the y coordinates. Order does not matter. All right, as far as what x coordinate you plug in first. Here's why. Ready? Let's say my x coordinates are 5 and 3. Will I still get the same result if I do 5 minus 3 versus 3 minus 5 and square it? 5 minus 3 squared. 3 minus 5. -2, square it. So either way, you're going to get out positive 4. So the order does not matter. You plug them in. Everyone okay? All right, let's apply it up above now. Let's go back to our problem up above. Give me the x coordinates. What are the x coordinates for this one? 4 and 2, again, doesn't matter the order I put them in. 4 minus 2